I meet a lot of students on a daily basis who come to me and say that, sir, I am facing problem in continuity. Continuity हो नहीं रहा है मुझसे, उसके problem नहीं solve होते हैं. So in this video, in order to help you out, I have divided all previous year questions that came into JEE Mains from 2019 onwards to 2025 into 7 types of problem solving strategies, so that you will easily understand that if a continuity based question is given to me, how to go about it, which strategy to use and how to solve that question. So without any further delay, let us jump into it. Now this is the mind map where we systematically start with the meaning, the idea of LHL, RHL, go into classification of discontinuity, algebra, continuity of functional equations, continuity in an interval, composite function, intermediate value theorem, and a single point continuity. But from practical point of view, let us jump on to type 1. Now type 1 questions are based on continuity at a point. Now in order to find continuity, you should understand that there are two things that are very important. One is the idea of LHL, that is left hand limit. So at a point x equal to a, if I want to find left hand limit, it is defined as limit h tends to 0 f of a minus h. And the right hand limit is defined as limit h tends to 0 f of a plus h. Now for a limit of a value of a function at a point to exist, the value of LHL should be equal to RHL. That would mean the limit should exist and should be equal to value of function at that point. Now practically when solving question, this definition is more useful in context of applying limits. Now if I look into this 2025 question, technically I can find LHL, RHL. But an even better technique in such question is, instead of finding LHL, we can find the limit of the function using the function that is smaller than 0, since we need to work on the value at x equal to 0. So directly instead of finding LHL, we are finding limit h tends to 0. The limit of the function that is given to me, that is sine of k1 plus 1 into x plus sine of k1 k2 minus 1 into x. You can clearly see that this is 0 by 0 form. So I can use L'Hopital to get my answer. So here, not h, x. If I apply directly L'Hopital, this becomes 2 times cos of k1 plus 1 into x into k1 plus 1, and then plus cos of k2 minus 1 into x into k2 minus 1, and the differentiation of x comes out to be 1. Now if I put the value of x as 0, this comes out to be 2 times k1 plus 1 plus k2 minus 1, and it becomes 2 times k1 plus k2. Now we also know that the value of LHL should be equal to value of function at point for the limit to exist. So the value of 2 times k1 plus k2 will be equal to 4. As a result, the value of k1 plus k2 comes out to be 2. First equation. Now we'll repeat the same process for RHL. So in the third part, in order to find RHL, we'll take the function on this side and then again do the same thing. X tends to 0, 2 by x log of 2 plus k1x, and now I am applying the property of log and writing this as log of 2 plus k2x. Once we have done this, we can again see that this is 0 by 0 form, so apply L'Hopital rule. So limit x tends to 0, 2, this will become 1 upon 2 plus k1x into k1. This becomes 1 upon 2 plus k2x into k2, and denominator differentiation is x only, that becomes 1. If I put this value of x as 0, this comes out to be 2 times k1 by 2 minus k2 by 2. This is what we are getting. So in short, we got this value as nothing but k1 minus k2. Now this will also be equal to value of function at that point, that is 4. So k1 minus k2 also comes out to be 4. Now k1 plus k2 is 2, k1 minus k2 is 4. If I add both of them, in the fifth part, I get 2 times k1. If I add this equation here and this equation here, will be equal to 6. The value of k1 comes out to be 3. And if k1 is 3, the value of, if I subtract them, that is 2 times k2, comes out to be minus 2. So K2 comes out to be minus 1. So now if I look into what I need to finally figure out is K1 square plus K2 square. Now that value will come out to be 3 square plus minus 1 square. That will come out to be 10. So the B option comes out to be. Now we can see that similar kind of question was asked again in 2025. Now again we will find LHL. So it is limit x tends to 0, 1 plus ax raised to the power 1 by x. So directly by definition, you can say that this value will be equal to e raised to the power a. This we already know. Now, if I want to find in the second part RHL, I will use this part of the definition. So again, limit x tends to 0, x plus 4 raised to the power 1 by 2 minus 2 by x plus c raised to the power 1 by 3 minus 2. Now here we can see that it is 0 by 0 form. For this to become 0 by 0 form, then only this will become finite. So for that to happen, what should happen is, if I put x as 0, let us see what do we get. If I put x as 0, the numerator will become 2 minus 2, that would become 0. And denominator will become c raised to the power 1 by 3 minus 2. So for this to become a finite quantity, it should be of 0 by 0 format. Numerator is already 0, denominator also needs to be 0. So c raised to the power 1 by 3 minus 2 becomes 0. The value of c as a result comes out to be 8. So once you have done this, the limit reduces itself into limit x tends to 0, x plus 4 raised to the power 1 by 2 minus 2 by x plus 8 raised to the power 1 by 3 minus 2. Now this is a 0 by 0 form, and if I want to find limit, I am going to differentiate this. So the numerator will come out to be 1 by 2 x plus 4 raised to the power minus 1 by 2. Denominator becomes 1 by 3 x plus 8 raised to the power minus 2 by 3. If you put x as 0, this becomes 1 by 2. This part also becomes 1 by 2. This is 1 by 3 into 1 by 4. As a result, the answer comes out to be 3. Once you have got this, now let us equate the value of LHL, that is e raised to the power a, to the value of RHL, that is 3, to the value of function at that point, that is 1 plus b. So e raised to the power a comes out to be 3. The value of b comes out to be 2. And c we already figured out was 8. What they are asking is multiplication of all these 3. So 3 into 2 into 8. So 6 into 8 is nothing but 48. So option B comes out to be correct. If I look into this 2024 question, this also, all of these questions are based on similar technique. There is nothing new. What is changing in each of these questions is how you are coming and figuring out the limit. But fundamentally, these all are the same questions. So you can use similar technique. You can solve all of these questions till 2019 using the similar technique. So I have put all of these questions in your lecture notes so that you can refer back these questions and solve using similar technique. Now, next category of questions are based on piecewise defined function, especially involving modulus, fractional part, greatest integer function. And in such questions, LHL, RHL based technique works the best. Let us look into this 2024 question that was based on this idea. You can see that the function involves fractional part of x. They have clearly mentioned it in the question. Until and unless mentioned, don't assume every bracket to be GIF or fractional part. Once you have done this, now first step would be to find LHL, that they have referred to as L. So now we will have to use the actual definition. Limit h tends to 0, f of 0 minus h. Now here, if I apply this, this will become cos inverse of 1 minus h whole square. It becomes sine inverse 1 minus h, and in the denominator it is minus h fractional part minus h fractional part whole cube. Now after doing this, important idea would be to figure out the value of fractional part of minus h. Now what is happening is, if you have very good grip over fractional part and GIF based properties and graphs, all of these questions becomes really simple because you'll have to use here and there minor things. So it is very good idea to revise basic things before jumping on to questions like this. Now here we know that if I am looking into fractional part of 1 minus h, it becomes 1 minus fractional part of h. And since h lies between 0 and 1, the value of this part will also become 1 minus h. So this is the interpretation, and once you do this interpretation, you will see that the question becomes very simple, because it is cos inverse of 1 minus h whole square sine inverse of 1 minus h, and ultimately what we have is 1 minus h minus 1 minus h whole cube. So you can see that the whole problem generating fractional part is gone now, and it has become a simple limit that can be easily calculated. So let us go forward and do that. So this becomes minus h square plus 2h, and if I simplify the next one, it becomes h, and denominator I can take 1 minus h common. What is left with us is 1 minus h whole square, that is minus h square plus 2h. Now here you can see that if I look into the first function, cos inverse of 0 is equal to pi by 2, so there is no issue in this part. You can see that there are certain parts which are generating no issues. That is my cos inverse part and this part. So whatever is not generating any issue in the limits, don't play with that. Just let us keep those terms aside. So this will become limit h tends to 0. Let us park cos inverse of minus h square plus 2h on one side. Also let us park this 1 minus h, and you can see that if I take h common, this will become minus h plus 2. So what you are ultimately left is sine inverse h by h. And now we know that this limit is equal to 1. So now let us put the values and see what is the answer. So if I put h as 0, this becomes cos inverse of 0. Denominator will become 1 into 2. Cos inverse of 0 is pi by 2. By 2. Answer becomes pi by 2h. Pi by 4. You can see that LHL we have sorted. Now let us move to the RHL part. So for doing RHL, it is simpler, because if I take RHL, this will become cos inverse of 1 minus h, fractional part of that, sine inverse of 1 minus fractional part of h, divided by fractional part of h minus fractional part of h whole cube. Now here the interesting thing is, if you are looking for positive values of h, that also very small, very close to h. In this case, this could be interpreted as h only. So again, we get rid of the fractional part that was creating a problem. So cos inverse of 1 minus h square into sine inverse of 1 minus h divided by h minus. Now if I write this limit as limit h tends to 0, cos inverse 1 minus h square by h into sine inverse of 1 minus h by 1 minus h square. But you could observe, see, this is determinate limit. This is not posing any problem. My problem is because of this part. So only in this part, since you can see that this is 0 by 0 form, I can apply only in this part L'Hopital. So this becomes limit h tends to 0 minus 1 upon root of 1 minus h square whole square. Differentiation becomes minus 2h, and in the denominator the part is there, that differentiation becomes 1. And since this is another limit, I can just copy paste, and the other limit can just be copy pasted down. I am only applying my operation in the first part because second one is determinate limit. There is no need of applying there. Once I do that, now let us see what is the answer. After applying this, now if I simplify this, I am getting limit h tends to 0 twice of h by root of 1 square, and this will cancel out, will become minus of h raised to the power 4 plus 2h square. And what we have is limit h tends to 0 sine inverse of 1 minus h by 1 minus h square, which is a determinate limit. We are just carrying it forward. One last step and we have got our answer. So now you can see that I can cancel out h square powers from here. This will cancel out, and now we can directly substitute the limit. So this becomes 2 by root 2, and here if I put h as 0, this becomes pi by 2. So your answer now comes out to be pi by root 2. Now let us go back to the question. Question says that 32 by pi square, by pi square L square. So L was nothing but pi by 4, if you remember. If I take this value, this will become pi square by 16. And RHL has come out to be pi by root 2. So if I square pi square by 2. And now if I multiply this, you can see that pi square is getting cancelled out. The first part will become 2. Second will become 16. If I add them, the answer comes out to be 80. Now again, if I look into this 2024 question, I can apply the same technique. So what I will fundamentally figure out is right hand limit. So for right hand limit, we will have to consider this function, and for left hand limit, we will consider this function. Now before starting the question, it would be little bit logical in this case to factorize x square minus 7x plus 12. So if I have x square minus 7x plus 12, we can write this as x minus 3 into x minus 4. This is what we can do. Why is this so important? Let us write now LHL and check. So once we are writing LHL, limit h tends to 0, f of 3 minus h would come. That would be interpreted as limit h tends to 0, 3 minus h. Now here, this is written as a into minus, we can take common. And here, if I put 3 minus, so that would become 3 minus h minus 3 and 3 minus h minus 4. And in the denominator part, if I do the same thing, there is already a b here. Modulus of 3 minus h minus 3 and then 3 minus h minus 4. So what you can observe here is, this comes out to be limit h tends to 0. You have a minus a by b. This simplifies into minus h. This becomes minus 1 minus h. The denominator part will again becomes mod of minus 1 minus h. And which in turn can easily be written as limit h tends to 0. Taking all minus signs apart, minus a by e h into 1 plus h. And this will become also h into 1 plus h. Since h is positive, it could be taken out. So the mod goes away, and now this whole thing will get simplified as minus a by b. In the second part, that is RHL. Now we'll write limit h tends to 0, f of 3 plus h. Now if I apply this, let us see what do we get. So for this, we'll have to consider this function. So 2 raised to the power sine of 3 plus h minus 3 divided by 3 plus h minus GIF of 3 plus h. Now once we write it like this, you can very easily observe that GIF of 3 plus h is a quantity between 3 and 4. So this GIF specifically can be written as 3. So this becomes limit h tends to 0, 2 raised to the power sine h. This will become 3 plus h minus 3. And you are getting sine h by h, that in turn will become 1. So that becomes 2 raised to the power 1. Now let us go back to the core idea that LHL, that is minus a by b, should be equal to RHL, that is 2, and should be equal to value function at that point, that is given as b. So if I write this out, you can see that the value of b comes out to be 2. Minus of a by b is also 2. Since b is 2, a comes out to be minus 4. Now let us see what they are asking. What they are saying is GIF S denotes the set of all ordered pairs A and B. Then the number of elements in S is, you can see that there is only one such combination possible, that is minus 4, 2. So you can see that your answer comes out to be option D. Now all of these questions that we have solved, both of these questions involve the hardcore idea of getting LHL and RHL by technically applying it. And then there are small property inputs that are happening from fractional part and GIF of x. So if I understand these two combinations, I will be able to handle questions that were asked in 23, that was asked in 2021. Again, this is the same question that we just solved. another that question that was asked in 2020, and this 2019 question as well. All of these fundamentally are centered around the core idea that we discussed in this LHL RHL. Now I know that you might have still got some if again there is more difficult question based on piecewise defined function, than what to do. So we have one more technique, that is interpretation based technique. So if I look into this 2020 question, the interesting part in this question is the first two functions, first and the last one, both of these are modulus functions, and we know that modulus functions are always continuous. So what does that mean is, I do not need to check for continuity for either of these functions independently. So what I need to worry about is how I am going to interpret this middle part. So now let us start with that. So if I have 4x square minus 1 ka greatest integer function. Now if you look into this, at minus 1 this function will become 3, and at plus 1 also this will become 3. So if I look into the graph, let us understand what is happening. So the graph of 4x square minus 1 looks something like this. So the values at which this become integer is, this is minus 1 at 0. Another value when it becomes integer would be this value. Then it is going to directly become 3 at minus 1. So in between it needs to become 1 also and 2 also. What I am saying is, at all integral values minus 1, 0, 1, 2 and 3 we can draw lines. What we need to understand is, at this value, when it becomes 3 it will approach minus 1, this will approach. So these values we understand. Now what happens in between, that we need to figure out. So for figuring out middle values, what you can understand is, if you have 4x square minus 1, this will be equal to 2 when 4x square becomes equal to 3, or x is equal to plus minus root 3 by 2. So what we need to understand here is, this value is corresponding to a point that is minus root 3 by 2, wherein this value here is corresponding to a point that is plus root 3 by 2. If I talk about plus 1 values, what you will have to do is put 4x square minus 1 is equal to 1. So 4x square will be equal to 2. X square becomes equal to 1 by 2. And as a result, x is equal to plus minus 1 by root 2. Once I understood this, this value also we can understand would happen at minus plus 1 by root 2. And this value will also happen at minus 1 by root 2. So now if I want to interpret the whole function, let us understand how it is going to look like. So in the second part, I can write my fx. So at one end, I have this modulus function that we know by definition are continuous. So I do not need to reinterpret this. So for x smaller than or equal to minus 1, we have these values. But for values of x between 1 and minus 1 and minus root 3 by 2, this is going to become, it is going to lie between, you can see the graph here, what is happening. It is going to lie between minus 2 and 3. So the graph is going to become equal to 2. Same thing here, same thing here. So this becomes equal to 2. And then if I look into the values of x between minus root 3 by 2 and minus 1 by root 2, what we could understand is the value lies between 1 and 2. So as a result, the answer will become equal to 2, equal to 1. And for values of x between minus 1 by root 2 and minus 1 and minus 1 by 2, the value will become 0. And then this cycle reverses. So it starts with minus 1 by 2. Between this value to 1 by 2, you can see that it will become minus 1. That The graph would be here below. And then for the values of x between 1 by 2 and 1 by root 2, this will again become 0. And fundamentally, starting at 1 by root 2 to root 3 by 2, this will again become 1. And for values of x between root 3 by 2 and 1, it again becomes 2. You can see that your GIF of x is getting divided into this many parts. Now, if I look beyond that, we know that it is going to be x plus 1 mod plus x minus 2 mod for values of x greater than or equal to. See, we do not need to worry about the modulus parts because we know that the modulus parts are always continuous. So now you can clearly see that how many points of discontinuity are there. So if I understand and if I analyze it further, you can see that 1 will happen at root 3 by 2, then 1 by 2, then 1 by root 2, 1 by 2, then 1 by minus 1 by 2, 1 by 2, 1 by root 3 by 2. So these values are almost given. What we need to check is basically what happens at minus 1. So if I look into the right hand limit at minus 1, this can easily be figured out by putting minus 1 here. So if I put minus 1, let us see what happens. So this value comes out to be 2 into 1 plus 3 minus 7 on. This will become my left hand limit. So if I calculate this value comes out to be 5 minus 2. That would be 2. You can see that at minus 1 it is continuous. And if I check it at 1, from here I will get my right hand limit. So if I put this value here, this comes out to be 1 plus 1 mod plus 1 minus 2. That value would be 2 plus 1. That would be equal to 3. So you can see that on the right hand side, it is not continuous. So if I look into the points of discontinuity now, you can clearly see that at minus 1 it is continuous. The first point will come at minus root 3 by 2, then minus 1 by root 2, then minus 1 by 2, then plus 1 by 2, then plus 1 by root 2, and then root 3 by 2. And ultimately you saw that it came at 1. So how many points? 1, 2, 3, 4, 5, 6, 7. So there are 7 points of discontinuity. So in this question, what we did was we reinterpreted the function GIF using graphs and we were able to understand the point of discontinuity. Again, in this 2022 question, we can apply the similar technique. So if this function is given to me, you can see that in the first part, if I analyze e raised to the power x, this is always smaller than 1 for values of x is smaller than 0. And as a result, if you are writing greatest integer function of x, it will become 0. Wherein, if I look into the next part, what it talks about is a into e raised to the power x plus greatest integer function of x minus 1, I can take minus 1 outside. And we are looking for values between 0 and 1. So again, this can also be analyzed and written. The greatest integer function becomes 0, a e raised to the power x minus 1 for values of x between 0 and 1. If I look into the third part, it talks about sine pi x. Now, if you look into the graph of sine pi x, how does it look like? So sine pi x, the period is going to be 2. So this is 1, this is 2, this is 0. If I am looking for values between 1 and 2, 1 included, you can see that between 1 and 2, it is negative, except the value at 1, where it will become 0. And after that, if you take any value, it becomes 0. So I can write it into two parts. It will become b when x is equal to 1, because sine pi x will become 0. But for values of x between 1 and 2, this will become b minus 1, because the values of sine pi x will lie between minus 1 and 0. Now, if I look into the last part, let us also see that it is e raised to the power minus x. See, e raised to the power minus x is between 0 and 1 for values of x greater than 0. Here, you can see that if I am taking for values of x greater than or equal to 2, so by default, e raised to the power minus x in this duration will be equal to 0. And as a result, what I can do for this last part is, I can write this function as minus c. So this becomes minus c for all the values of x greater than or equal to. If I rewrite this, let us see how it looks like. So what I have as fx is, for values of x is smaller than 0, it is 0. For values of x between 0 and 1, it comes out to be a into e raised to the power x minus 1. For values of x equal to 1, it becomes b, and for values of x between 1 and 2, it becomes b minus 1, and for values of x greater than or equal to 2, it becomes minus c. Now, after this, the question actually starts. Now, what they're saying is there exists a, b, c belongs to R such that fx is a continuous function on R. So, for this to become continuous, now let us see what are the possible things. For this to become continuous, this left hand limit and right hand limit at 0 needs to be equal. So, what should happen is 0 should be equal to, if I put x equal to 0, this will become a minus 1. So, for continuity at this point, a needs to be equal to 1. If I want to ensure continuity at 1, the left hand limit will come by putting 1 in this function. So, a into e minus 1 should be equal to b. For continuity, we should also want to have this value equal to b minus 1. Now, this is almost impossible, so this can never happen. And now, for 2, what is the condition that we should have? B minus 1 should be equal to minus c. This is possible. So, now let us analyze the option in this slide. So, you can see that if I look into the option C, what they are saying is a plus b plus c. Now, let us see first option B. So, if f is discontinuous, it's exactly 1 point. So, definitely at 1. And in that scenario, a is definitely equal to 1. But if I look into other value, b plus c should be, from here we get b plus c is equal to 1. So, if I add these two, what I will fundamentally get is a plus b plus c should be equal to 2 and not 1. And hence, this option is also incorrect. This is incorrect. But you can see that C option hence will become correct and will become our answer. Now, this next question is based on interpretation of functions. Now, here what we are going to understand is this: sometimes functions are written using limits also. Like in this case, we could have 3 different cases, in fact 2 different cases. So, now what we can have in case 1 is, if I consider the value of x square as greater than 1. If I consider the value of x square as greater than 1, so when n tends to infinity, x raised to the power 2n will also tend towards infinity. And as a result, if you want to find the value of this function, we will have to divide it by x square, x raised to the power 2n. So, this becomes cos of 2 pi x by x raised to the power 2n minus sine x minus 1 divided by 1 upon x raised to the power 2n plus x minus 1. Now, if you put this limit, you will be able to understand that the answer comes out to be minus of sine x minus 1 by x minus 1. Wherein there can be a case 2 when x square is smaller than 1. If this happens and n tend towards infinity, if I put a very big power over x square, this value will actually be equal to 0. And as a result, my function now, in this, if I write this value, you can see that can be written as cos 2 pi x minus x raised to the power 2n sine x minus 1 by 1 plus x raised to the power 2n plus 1 minus x raised to the power 2n. So, x raised to the power 2n here, now you can see is written here, here, here. All of these terms will become 0. As a result, my answer becomes cos 2 pi x by pi. This is what is happening. So, there could be a case 3 when x is equal to plus 1. If I consider this value, now the value of f of 1 becomes limit n tends to infinity. If you put 1, this becomes cos of 2 pi minus sine of 1 minus 1 divided by 1 plus 1 minus 1. And as a result, you can see that this comes out to be 1. On the other hand, we could have a case 4 also. In that, we can consider the value of x is -1. So what we are doing is, for different values of x, we are trying to understand what can be the interpretation of the function that is given above. So I can put -1. Now this becomes limit n tends to infinity. We will have cos of 2n pi into -1. The next function that is written will become minus of sine of -1 divide by, so answer comes out to be 1 plus -1 raised to the power 2n plus 1 minus 1 raised to the power 2. So if I write it now, you can see that the value of this function, in fact, n tends to infinity, won't be required now. So this part will become +1. This part, if you look into, will become sine 2. And the denominator part will become 1 minus 1 minus 1. That is, this cancels out, becomes minus sine 2 minus 1. This is what we are getting. So if you write the function now, the whole function, let us see what are we getting. For values of x square smaller than -1, we'll have -1, and we'll have between -1 and 1, x square equal to 1, then x square greater than 1. So these many parts of the function we will have. So if I write all of these parts of the function, what am I getting? So in the first part, you can see that when x square is greater than 1, so the function becomes minus sine x minus 1 by x minus 1. So this is the value we'll get here also and here also. Wherein when the function becomes -1, the value was sine minus sine 2 minus 1. And at 1, we figured out it is equal to 1. And in between, we figured out the value was equal to sine 2 pi x, cos 2 pi x. Now here, you can clearly check and understand that the discontinuity is clearly happening at -1 and 1. So option B in this case comes out to be correct. Now this 2019 question can be similarly solved. Here again, if you want to interpret this function, let us interpret the first part. You can see that since we are looking between, we can split this up. What happens between -1 and 0? Then what happens between 0 and 1? And then what happens between 1 and 2? And then again, what happens between 2 and 3? And ultimately, what happens at 3? We can split this function like this. So at between -1 and 0, the value of greatest integer function becomes -1. Mod will open with a negative sign. So minus x minus 1. Between 0 and 1, GIF becomes 0. This becomes x. Between 1 and 2, you can clearly see that the mod will open with a positive sign. So becomes 2x. And the last part, now here you can see between 2 and 3, this becomes 2. So x plus 2. And ultimately at 3, if you put the value 3, this becomes 3 plus 3, 6. We have got the function. So now if you check this, you can see that what are the points of discontinuity? So the points of discontinuity will only arrive when the value of the function is changing. So at 0, you can put the value here and get the left hand limit. So you can see that the left hand limit comes out to be -1. The right hand limit comes out to be 0, and this is not equal. Hence, it is discontinuous. At 1, you can see that the left hand limit becomes 1, wherein the right hand limit becomes 2. So again, it is not equal. So discontinuous. Again at 2, the left hand limit will become 4, wherein the right hand limit will also become 4. So this is equal. This is fine. But if I check at 3, you can see that the left hand limit is coming out to be 5. Right hand limit is coming out to be 6, and it's not equal. Discontinuous. So you can see there are 3 points of discontinuity. The option C comes out to be correct. Now another technique of checking continuity is based on algebra of continuity. Now what is this? Now let us say that you have two functions. One is fx, another is gx. And let us say that both of these functions are continuous. Another case, this is continuous, this is discontinuous, discontinuous, continuous, and both discontinuous. So now what we can comment on their addition. So if I add these two functions, this function is going to be continuous. wherein both of these functions are going to be discontinuous. Wherein if I subtract this function, again the same relationship will follow. But in all other cases, that is multiplication, division, and all of these cases, when both the functions are discontinuous, we will have to actually solve and check. But it is a great help to know that if there is a sum or a difference of a continuous and discontinuous function, it is always discontinuous. Wherein if there is sum of two continuous functions, it is always continuous. In fact, we know that their multiplication and division is also going to be continuous, provided that GSK is not 0 in case of division. So this part we can comment on, wherein we can't comment on the remaining parts. This is what is known as fundamental algebra of continuity, becomes very useful in case of addition and subtraction of functions. Now let us look into this 2024 question. Question says that a function is given as 2x square plus x plus greatest interior function of x square minus GIF of x. This GIF is the main thing that is stopping us to comment on the number of points of discontinuous nature of this function. So what we can do is, now if you carefully observe, there are three parts of the function. One is 2x square plus x, which is a polynomial, and this one is always continuous. So this is sorted, there is no issue with this. If you look into x square ka GIF, and if I am looking into values between -1 and 2, where it will become discontinuous is whenever your x square will become an integer. So these are the points where it will become discontinuous. So it will generate points of discontinuity when I put value as -1 at 0. Then it will become discontinuous at 1 and ultimately at √2 and √3 and then fundamentally at 2. You can see that this many points would be the points of discontinuity for this function. Again, if you look into greatest interior function of x, similar kind of story will also be there. So this will become discontinuous wherever x becomes an integer, and that is going to happen at -1. That is going to happen at 0. That is going to happen at 1 and ultimately at 2. You can see that what is happening is, where are these points of discontinuity going to happen? So now what is going to happen is, since these two, if I am adding these two first, let us say that these two are a sum of a continuous and a discontinuous function at -1. So at -1 this will become discontinuous, the sum of the first two functions. This will also become discontinuous, 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 discontinuous. Okay, so all these points are going to be discontinuous. Wherein if I look into the points and where this is discontinuous and the other function is continuous, you can see that at this point this is continuous, this is continuous. So we can clearly comment on these points that it will become a sum of a discontinuous and a continuous function. So this becomes discontinuous. So here we can directly comment. Now you can see that after doing this, we will have to check the value of this function at these many points, -1, 0, 1 and 2. So out of 6 points where I need to have to actually check the condition for continuity, I was able to make it down to 4 just by having right kind of algebra into place. Now what I can do is, after this I can interpret this function only about these points and get my answer, and from there I will be able to tell you. In the first part I was able to shortlist over these points, and now here I can't comment because it is sum of two discontinuous functions, and for that there is no algebra. So what I can do is I can check what happens to this function. So for that I am interpreting this function. So if I interpret this function at -1, let us see what do I get. So if I put the value as -1, the first part will become 2 into 1 minus 2. So this will become 1. Greatest interior function of -1 ka square will become +1 and then -1. So you can see that this comes out to be 1. Wherein if I am looking for values between -1 and 0, now 2x square plus x will remain, wherein between -1 and 0, x square value will be between 0 and 1. and between 0 and 1, I do not need to check exactly at 1. The value will be between 0 and 1, hence this part becomes 0. For GIF, this value will be between 0 and -1, hence becomes -1. So this becomes +1. For value at x equal to 0. Now at x equal to 0, you can see that the whole thing becomes 0. For values of x between 0 and 1, now this becomes 2x square plus x. This function again becomes 0, this also becomes 0. For value of x at 1, we can clearly see that if I put 1 everywhere, this becomes 2 plus 1 plus 1 minus 1. So this cancels out, becomes 3. Now I could have checked the value between 1 and root 3. This is another place I need to check, 1 and root 2. So between 1 and root 2, you can see that this becomes 2x square plus x. Now x square is going to be between, so this will become 1. This also becomes 1. This again cancels out. If I take values between, see now this is root 2 to root 3. So you can see that this interpretation now I can let go. I do not need to do this because we already understand what is going to happen. I will have to also let go at what happens at root 3. So directly I will jump onto a point when I am checking between root 3 and 2. And ultimately at x equal to 2. So in this value, this becomes 2x square plus x. This becomes 3. This becomes 1. And x equal to 2. This is 2 into 2 square plus 2. This becomes 4 minus 2. Now if I check value at all the integral points, I will get my answer. So let us understand what is going to happen at -1. So at -1, the left hand limit is -1 plus 1. Wherein the right hand limit, if you put 1 here, -1 here, it's going to become 2 minus 1, that is also 1. So this becomes 1, it is fine, it is continuous. If I check at 0, you can see that the whole thing becomes 1. So this becomes 1. The right hand side is 0, so it is not equal. You can see that this is discontinuous. Now if I check at 0 again here, I do not need to do that because we have already figured it out. What I can do is I can check at 1. So at 1, if I put the value in the left hand side, it becomes 3. On the right hand side again becomes 3. So this part is fine, but I will also have to check here. So here also if I put it becomes 3. This is also fine. So this at this point it is somehow sorted. So continuous. Now if I want to check at root 2, I do not need to. I just have to check at 2. So at 2, the left hand limit comes out to be 4. This will become 8 plus 2 plus 3. So this is total 13. But in the right hand side, if you check the values, this is 4 into 2, 8, 8 plus 2, 10, 10 plus 4, 14, 14 minus 2, 12, so not equal to 12. So this here it is discontinuous. So what we can understand now is if I look into the total number of values, so at -1, so what are the points of discontinuity now? Let us count them. So at -1 we figured out it is continuous, but at 0 it was discontinuous. And at 1 again we figured out it was continuous, but at 2 it was discontinuous. So it is discontinuous as 0, root 3 and then again 2. So there are 4 points of discontinuity. That comes out to be option C. So a combination of algebra along with what we learned earlier helps us solve these questions fast. Now if I look into this 2024 question, it can again be simplified using algebra. So now if you look into this function fx that is given to us, first function, that is x by 2 plus 3, can be reinterpreted as x by 2 ka GIF plus 3 minus root of x. So now you can see that this function will become continuous and discontinuous based on the values of GIF involved. Now first GIF will become discontinuous whenever x by 2 is integer. That is going to happen at 0. Then it is going to happen at 2. Then it is going to happen at 4, then 6, and then ultimately 8. Wherein the second one will become whenever the root x will become an integer. That is going to happen at 0, then 1. Then ultimately this is going to happen at 4. And then after that 9 will come, that is not in the interval 0 to 8. If I stick to this interval. Now we can see that when I am doing this in the first part, it is a sum of a discontinuous function and a discontinuous function. We won't be able to say anything. But at this point, this is continuous, this is discontinuous. This is discontinuous, this is continuous. This is again discontinuous, so we won't be able to say anything. Discontinuous, continuous, discontinuous, continuous. So if you see directly from the algebra part, we can say that I will be able, these are the points where it is a sum of a continuous and a discontinuous function. These are the points where it is going to definitely be discontinuous. So the points where discontinuity would happen for sure till this point of time are 1, then 2, then 6 and then 8. Where we need to check is, are the starting point of 2 and 4. These are the only 2 points we need to actually check. Now for doing that, we will analyze another function. See, we know that this 3 will have no impact in terms of discontinuity because it will just shift the graph above, and hence we will analyze another function that is simpler in nature, that is gx, that is x by 2 ka GIF minus root of x ka GIF. And for this can easily be interpreted. So what we'll have to understand is what will happen between 0 and 1, what will happen between 1 and 2, what happens between 2 and 6, 2 and 4, what happens between 4 and 6, between 6 and 8, and ultimately at x equal to 8. So here we need to understand. So between 0 and 1, you can see that both of these functions are going to lie between 0. This becomes 0 minus 0. At 1, you can see that this is still 0, but this will become 1. Between 2 and 4, the first function will still become 2, but the second function will remain 1. Wherein between this becomes 2 and 4, you can see that this is becoming, this will become 1 here. This will become 2, this will become 3, and this will become 4. At the same time, here you can see that between 4, this will become 2. This remains 2 thereafter. If you understand, you can see that in this interval, 0 minus 0 is becoming 0. So this value is still 0. 0 minus 1 is minus 1. This still remains 0. This will also become 0. This will remain 1. And 4 minus 2 is equal to 2, so this becomes 2. So you can clearly see that we only needed to check value at 0. Here it is continuous. And then at 4, you can see that the LHL and RHL both are 0. So this is also continuous. So this is sorted. You can see that ultimately we are left with the same 4 points that we started with. What they want to ask us is the sum of these 4 points. So 1 plus 2 plus 6 plus 8. This comes out to be 70. This is the answer to our question. Now similar technique can be applied in this 2023 question. Now this question in 21, and this question in 20 can also be solved using interpretation. Now next type of problems are based on continuity of composite function. Let us start with a simple question that came in 2022. In this question you can see that a function fx is given, a function gx is given. They are saying that function are continuous on R, then give us the value of g of f and fog of. Now here the question is simpler because they are not asking us to find the continuity of composite function. What they are asking is, they are telling us f and g, you figure out first using continuity and then give me the value. So what we can do in this question is just check the continuity in the first step for gx. For gx to be a continuous function, it needs to be continuous at 0. If you put 0, the left hand limit comes out to be 0 at 1. And the right hand limit will be at 0, again becomes 4 square plus b. So value of b comes out to be minus 15. So now you can see that this part of the function looks like x minus 4 whole square minus 15. Now in the second part, we can figure out the continuity of fx. This also needs to be continuous. So again, if I find the left hand limit at 0, it becomes a. The right hand limit again becomes 4. So a comes out to be 4. Moving ahead, I will have to figure out the value of this function at 2, g of f of 2. If I want to find this value, we already have to first figure out the value at f of 2. So f of 2, if you put here, the value will come out to be 2. So this becomes g of 2. And for that, you will have to put value here. That becomes 2 minus 4 ka whole square minus 15. That comes out to be minus 11. Wherein, if I have to find the value of f of g of minus 2, I will have to put minus 2 in the first function. So that will become minus 2 plus 1 minus 1. And then I will take this function and put in the first function. That will become minus 1 plus a, that is 4. Answer comes out to be 3. Now they are saying sum of these two functions. So you can clearly see that comes out to be -8, that is option D. Now a more complicated form of the same question can be asked in the form of this 2022 question, wherein they are asking us to figure out number of points of discontinuity of this f of gx. So for this, the steps are very simple. First, you will figure out f of gx. So if you figure out f of gx, in the function f, you will put gx, so that becomes 2 times g of x ka whole square plus 1 ka greatest integer function. Now this can be further interpreted by putting two different values of gx. So this can be written as 2 times 2x minus 3 ka whole square plus 1 ka greatest integer function. These values are therefore values of x smaller than 0. Then 2 times 2x plus 3 ka whole square plus 1 ka greatest integer function. These are the values for greater than equal to 0. Now, in order to understand what is going to happen to this function, you very clearly understand that now they have also given us that, then in the open interval -1 to 1. So now what they're saying is, if you interpret this function, let us first interpret, then write the second part of the question. So this will become 2 times 2x minus 3 ka whole square ka greatest integer function plus 1 for values of x smaller than 0. And this becomes 2x plus 3 ka whole square ka greatest integer function plus 1 for values of x greater than equal to 0. Now what they are saying is, if I substitute value between -1 and 1, if I substitute value between -1 and 1, how many points of discontinuity are there? So for that, what we need to understand is, what will be the points? Now this will become the first part of the function. If I am putting values between -1 and 0, these values will be interpreted using the first part, that is whenever 2 into 2x minus 3 ka whole square, this will become an integer, that would be the points of discontinuity. So if I draw the graph, you can easily understand that what is going to happen to this part of the function. So you can see that this point is going to come at 3/2 and the graph is going to be a parabola like this, wherein I want to analyze this between -1 and 0. So at 0, if you put the value in this function, you can see that this function comes out to be 9 into 2, 18. So this point is 18. And if I put -1, you can see that this value will become 50. Now since -1 and 0 are not included, you can see that this graph will become integer at values, this will become 19 when it will take value 20, and this will take value till 49. So whenever this will take these integral values, it will become discontinuous. If you count these values, these are nothing but 49 minus 19 plus 1. This is how you count it. So this comes out to be 31. This is one side of analysis. Now the similar kind of activity will also happen if I look for values between 0 and 1. So now you can see that if I look into values between 0 and 1, I will have to check for values at which 2x plus 3 ka whole square, this part of the function, this becomes integer. Now if you draw this graph, let us see what is going to happen. If I draw this graph, it will become 0 at -3/2. So at 0, you can see that this will become 18. Now this point is included here. And if I go till 1, 1 is not actually included, but I can go till 1. If I go till 1, you will see that again this number will become 5. 5 square into 2, 25 into 2 will become 50. So now you are taking values from 18 to again 49. These are the possible values. So corresponding to that, you will get 31 more values. So 31 points of discontinuity earlier, 31 points of discontinuity total. The total answer comes out to be 62. So you can see that in this question, there are two important steps. One is basically, first we figure out the composite function. Once you have written the composite function, we check the continuity or discontinuity of that composite function. Now, if I look into this 2022 question, we have two techniques of finding fog of x. So the fundamental method remains same. First, we are going to find f of gx, and then we are going to find its continuity. But we can find f of gx faster if I use the graphical method in this case. So what I am saying is, in order to find graphical, and if you are not comfortable with this, you can use the usual method of substitution. But this is faster, so I am trying to tell you. Now here, what you will have to first do is draw the graph of gx. Now, whatever is the inside function, in this case, the inside function is e raised to the power minus x. Now, by this second function, if you simplify, will become x square minus 2x. So, what we can do is draw the graph of e raised to the power x minus x. So, that graph is going to look like this. If you are not comfortable, you can use graph curve tracing to do it. And then here it will become between 0 and 2. So, this graph becomes like this. So, once you understand this much, this becomes a much simpler question, because now for finding the function f of gx in the second part, since the output of gx will become input for fx, so whatever is the categorization here, that will be reflected on y-axis. So that would mean this is my 0. The values below this, that is smaller than 0, will go into GIF of x, and the values greater than this will go inside 1 minus x comma. Now, if you look into this part of the function, let us see what is happening. So, this part of the function is e raised to the power x minus x. This occurs for values of x smaller than 0. Now, this will become input for this function, and then output as a result will be generated as 1 minus e raised to the power x plus x comma. And this is happening for values of x minus 1 to 2. So, one more value will take what happens at 0. So, at 0 you can see that this function is becoming 0. So, that x equal to 0 pe, the function is becoming 0, that value will go into this function. As a result, it will become 1 minus 0, it becomes 1. And then for values between 0 and 2, you can see that the value is smaller than 0. So, this part, that is x square minus 2x, now will go inside this function. You can see that this value lies between is x square minus 2x, but since it lies this x square minus 2x, this lies between minus 1 and 0. The GIF of this is going to become minus 1 only. So, between minus 0 and 2, the function becomes minus 1, and ultimately for values of x greater than equal to 2, this x square minus 2x will enter this function, because now you can see that this graph is above x-axis. So, this becomes 1 minus x square plus 2x comma. For those who do not understand this technique very well, I will highly advise that you watch my composite function recordings on the YouTube. That will largely help you out. Now, once you have understood this, you have got the function. Let us rewrite the function and then check its continuity. If I rewrite this function, you can see that you have 4 parts into it. What happens when x is smaller than 0? So, this becomes 1 minus e raised to the power x plus x comma. What happens when x is equal to 0? So, you can see that this becomes 1. What happens between 0 and 2? It becomes it becomes minus 1. What happens for values of x greater than or equal to 2? It becomes x square minus 2x minus 1 comma. So, now the obvious points to check continuity are to what happens at 0 and what happens at 2. So, 0 you can clearly see that from here it is discontinuous. If I check it 2, I will have to figure out the left hand limit. The left hand limit is minus 1 only. For right hand limit I can put 2 here. So, that comes out to be 4 minus 1 comma, that is equal to 1, and hence it is not equal to minus 1. So, this becomes discontinuous. I can clearly see 2 points of discontinuity. So, answer comes out to be option B. So, method remains very simple. First you find fog and then you find the continuity of that fog. If you can't do using graphical method, use simple algebraic method to get the answer. Now, using similar method, you can do this 2021 question as well. Now, this next type of questions are based on mixed concept. So, if I look into this 2024 question talks about gx being a linear function. So, a linear function can be written as ax plus b. Now, in order to get this function, which will be essential to get the value of 3, we'll have to get the value of a and b. Now, for that they have given 2 conditions. One, it is continuous. So, for continuity, we can get the left hand value as g of 0. This is my left hand limit, but this should be equal to right hand limit. Now, for finding the right hand limit, we'll have to get the value of this limit. Limit x tends to 0 1 plus x by 2 plus x raised to the power 1 by x. Now, if you look into this limit and x is tending towards 0, what is going to happen? When x tends towards 0, the function that is written inside, that is 1 plus x by 2 plus x, this will tend towards 1 by 2. And the power, if you look into power, that is 1 by x, this is tending towards infinity. We are looking at right hand side, so it is 0 plus. So once you look into this, if I raise 1 by 2 to a very big power, the answer is going to be 0. So this limit is actually equal to 0. And since left hand limit should be equal to right hand limit, the g of 0 value also becomes 0. So now what we have got is ax plus b. So a into 0 plus b is equal to 0. As a result, the value of b comes out to be 0. In the third part, they have given one more condition about differentiation. If I do differentiation at 1, so for finding differentiation, the function in the vicinity of 1 can be considered as 1 plus x by 2 plus x raised to the power 1 by x. So if I want to find this function, I will have to take log. For derivative, I will have to take log. So 1 by x, ln of 1 plus x by 2 plus x. This can be now differentiated on both the sides. So if I differentiate it, now differentiation of this function becomes 1 upon fx into f dash of x, and this we can apply product rule, can be written as minus 1 by x square into ln of 1 plus x by 2 plus x, and then plus 1 by x into differentiation. So this can be written as 1 upon 1 plus x minus 1 upon 2 plus x. Now once you have this, what they want us to do is find out the value of this function at 1. So if I put the value at 1, the f dash of 1 by f of 1, this value is going to be minus of ln of, you put 1, this becomes 2 by 3 plus 1 by 2 minus 1 by 3. This is the value that we are getting. You can see that we have got the value of f dash of 1 by f of 1. F of 1 we can figure out directly from here by putting value here. So if I put value as 1 here, my f of 1 comes out to be 2 by 3 and raised to the power 1. That is nothing but 2 by 3. So you can see that if I take this 2 by 3, so f dash of 1 as a result becomes 2 by 3 times minus ln of 2 by 3. And if I subtract this, 3 minus 2 will become 1. So that is nothing but plus 1 by 6. We have got the value of f dash of 1. Now what they are saying is equate this to f of minus 1. F of minus 1 would be the value of g of minus 1. So now in the third part, we will take f dash of 1 and equate it to f of minus 1. So this value is 2 by 3 times minus ln of 2 by 3 plus 1 by 6, and f of minus 1 would be equal to g of minus 1, and g of minus 1 is minus a plus b. B already came out to be 0. So from here the value of a comes out to be, since b is already 0, 2 by 3 ln of 2 by 3 minus 1 by 9. Now in the fourth part, what they are asking is value of g of 3, that would be equal to 3 times a. A we have already figured out. So this becomes 2 by 3 ln of 2 by 3 minus 1 by 9. This becomes 2 ln 2 by 3 minus 1 by 3. This can be further written as ln of 4 by 9. We can write 1 here as ln of e. So ln of 4 by 9 minus ln of e raised to the power 1 by 3. So if I write it down, this becomes ln of 4 by 9 e raised to the power 1 by 3. If you look into the options, you can see that C option matches. 60 days to JEE Mains. Let me tell you something that nobody else will. The brutal truth. Right now, you have doubts from class 11th you never cleared. Topics you are avoiding, formulas that you kind of remember. And you are thinking 60 days is enough to fix everything. Here's the reality. It's not if you study randomly. At PYQs, we have produced 10 times better result than national average and helped more than 500 plus students jump 80 plus marks in last 60 days. How? They stopped trying to cover everything and focused only on high weightage topics. They cleared every doubt, they had a strategy into place. And that's what Last Lab Booster program does. Senior IITian faculty sit with you and develop a 60-day roadmap. Expert teachers guide you 1:1 daily. Every doubt is cleared in 24 hours. Not random prep, but strategic warfare. Ashesh, Ditya, Sauri, Sarthak, we are all able to improve from 150 to 250 in a matter of 60 days. Real students, real result, 60 days. But time is less and our slots are even more limited. Click the link below, book a free strategy session or regret it on 1st Feb. 60 days, your move.